factor that render processes irreversible. There are many factors that make processes irreversible. Four of those factors are friction, unrestrained expansion, heat transfer through a finite temperature difference, a finite temperature difference, and mixing of two different substances. The first one is friction. It is readily evident that friction makes a process irreversible, but a brief stimulation must be amplified to point. Let a block and the inclined plane make up a system as this picture. And let the block be pulled up the inclined plane by weights that are lowered. A certain amount of work is needed to this. Some of this work is required to overcome the friction between the block and the plane, and some is required to increase the potential energy of the block. So some work is needed to overcome the friction and change the potential, increase the potential energy of the blocks. This block. The block can be restored to its initial position by removing some of the weight and thus allowing the block to slide back down to the plane. Some heat transfer from the system to the scenes the surrounding, as this picture. So at the reverse from A to C, some heat to the surrounding. So the surrounding is changed, was changed. As the result, the process is irreversible. reversible. Since the surroundings are not restored to their initial state and the conclusion of reverse process, we conclude that friction has rendered the process irreversible. Another type of frictional effect is that associated with the flow of viscous flow in a pipe, or the flow of viscous fluid in a pipe. We have also irreversible process. The next, unstrained expansion. Next factor, that unstrained expansion. The classic example of an unrestrained, let me make a correction here, unrestrained expansion is shown in this picture. This picture shows is a gas separator from a vacuum by a membrane. Consider that what happens when the membrane breaks and the gas fills the entire vessel. Initial state, we have a vacuum and gas with a membrane. Consider one. Membrane removed. And gas and the gas filled the entire vessel. It can be shown that this is an irreversible process by considering what would be necessary to restore the system to its original state. The gas would have to be compressed and heat transferred from the gas to reverse to the first state. We should compress the gas, so some heat transfer and heat transferred from the gas until its initial state is reached. Heat transferred to the surrounding, so we have Q out and work in. Since the work and heat transfer involve a change in the surrounding, so Q and W involve change in the surrounding. The surroundings are not restored to their initial state, indicated that the unrestrained expansion was an irreversible process. So we have unrestrained expansion. The process described in this picture is an example of the unrestrained expansion. In the reversible expansion of gas, there must be only infinitesimal difference between the force exerted by the gas and the restraining force, so that the rate of which the boundary moves will infinitesimal. In accordance with our previous definition, this is a quasi-equilibrium process. However, actual systems have finite difference in forces which cause a finite rate of movement of the boundary, and thus the processes are irreversible in some degrees. The next factor in the rendered process irreversible is heat transfer through a finite temperature difference. A finite temperature difference. Consider as a system a high temperature body and a low temperature body. And let heat be transferred from the high temperature body to the low temperature body. The only way in which the system can be restored to its initial state to prevent a refrigerator, at first we have, for example, a high temperature to the low temperature. So we have heat transfer from high temperature to low temperature, but at the T, for example, T second, to give to the gas would have to be the body with high temperature should be, we should use work to, for example, a Q H to the system to reverse to the first condition or first state, in this case work and heat transfer effects on the surrounding. So we have irreversible process. As interesting question now posed, heat is defined as energy that is transferred through a temperature difference. We have just shown that heat transferred through a temperature difference is an irreversible process. Therefore, how can we have a reversible heat transfer process? A heat transfer process approaches a reversible process as the temperature difference between the two bodies approaches zero. So we have a question, how can we have irreversible heat transfer process. A heat transfer process approaches a reversible process. Approaches a reversible process. As the temperature difference between the two bodies approaches zero. Therefore, we define a reversible heat transfer process as one in which the heat is transferred through an infinitesimal temperature. Heat transfer through infinitesimal process infinitesimal temperature difference. We realize, of course, that to transfer a finite amount of heat to an infinitesimal temperature difference would require infinite amount of time or an infinite area. We need infinite amount of time or infinite area. Therefore, all actual heat transfer are through a finite temperature difference and hence are irreversible. And the greater the temperature difference, the greater irreversibility. Temperature difference greater irreversibility. We will find, however, that the concept of reversible heat transfer is very useful in describing ideal process. The next one in factor is heat. Mixing of two different substances. This figure illustrates the process of mixing two different gases separated by a membrane at first. This membrane in oxygen and nitrogen. When the membrane is broken, a homogeneous mixture of oxygen and nitrogen fills the entire volume. This process will be considered in some detail in the chapter 13. We can say here that this may be considered a special case of unrestrained expansion. A special case of unrestrained expansion. We can say here that this may be considered a special case of an unrestrained expansion. For each gas undergoes an unrestrained expansion as it fills the entire volume. A certain amount of work is necessary to separate these gases. Thus, an air separation plant, such as described in Chapter 1, requires an input of work to accomplish the separation. Require work to separate these two gases into and two initial case. So it is an irreversible process. There is also some other factors such as a number of other factors make process irreversible. Make processes irreversible. But they will not be considered in detail. Hysteresis effect, and losses in containing electrical cycle are both factors that make process irreversible in electrical application. Circuits are both factors that make it is frequently advantageous to distinguish between the internal and external irreversibility. The next section is about the internal and external irreversibility for the